In this lesson, we are going to solve the integral of the square root of x plus 1 over x with respect to x. We will tackle this problem through a substitution method and partial fraction decomposition. Our objective here is to evaluate the integral in the simplest form. We begin by using substitution. Let's choose an appropriate substitution to simplify the integral. Notice the square root in the denominator. A good substitution is to let you equal the square of x plus 1. We begin by using substitution. Let's choose an appropriate substitution to simplify the integral. Notice the square root in the numerator. A good substitution is to let you equal x plus 1. Then we have two cases backslash sqrt x plus 1 equals backslash sqrtu, and as a result, x equals u, 1. Now, let's find the differential of u with respect to x, as this will help us change the variables later. Upon differentiating both sides, du over dx equals 1. With some algebra, we can express dx in terms of du. Since du equals dx, we have dx equals du. Now let's substitute everything back into the original integral. So the integral becomes the integral of backslash sqrt u over u1 u du. It looks complex, but it will simplify further. Let's apply partial fraction decomposition. To do that, we express the integral as follows to simplify our computation. Next, we multiply each term by the common denominator u1 to eliminate the fractions. We get backslash sqrt u equals a u1 plus bu. Now, let's plug in values for u to help solve for a and b. Let's first set u equals 1, which gives us backslash sqrt 1 equals a 1-to-1 plus b 1. This simplifies to 1 equals b. Now let's set u equals 0 to find a backslash sqrt 0 equals a 0-to-1 plus b 0. This tells us that 0 equals a. Therefore, a equals 0. All right, we know a and b now. We can substitute those back into the equation. Our equation is 0 plus rac1 u1. Now we can easily find the integral. The integral of rac1 u1 is backslash ln u 1. Finally, don't forget to substitute back in for u. And there you have it. We integrated the expression by choosing the appropriate substitution and applying the method of partial fraction.